Hello geometry students, welcome back to 9.2. We are finally on day 3 and this is our very last day of 9.2. 9.2 covered circles and it's going to cover these, we had 2 days for regular polygons. We spent our time yesterday looking at regular polygon apothegms. So this is a little bit of what our notes looked like. We were able to find the central angle, the perimeter, and the apothem. And I said that those are important because today we're going to find the area using the perimeter or using the apothem. So our essential question is, can I find the area of a regular polygon? And specifically any polygon that's a 5-sided figure or bigger, because we can find the area of a regular triangle, which would be an equilateral triangle, or a regular quadrilateral, which would be a square. So we're going to talk about regular polygons that are bigger than 4 sides. Now, we need an area formula that works for every regular polygon, and we actually have one. This probably isn't a formula that you've used before, but just like every other formula that we've used, you're going to plug in what you know and solve for what you don't know. That's kind of our theme, is to write this out, plug in what you know, and solve for what you're looking for. So I would like you to write that down, that the area is 1/2. And we're going to dissect this a little bit. That little a, so we use a big A for area, and that little a is the apothem, whereas the big P is the perimeter. So I have a little apothem and a big perimeter, and we're going to use that today. So our first question is, find the area of a decagon with a perimeter of 40 centimeters. So that's the first one that we're going to look at. And we need to kind of discuss a few things. We need to draw a little picture. I'm going to draw a little example. You wouldn't have to. And then we're going to plug in what we know. So I do know that the area formula is 1/2 times my apothem times my perimeter. Now some of this I know. For example, I know that my perimeter is 40 centimeters. So I'm going to plug that in already. So I'm already halfway there. I just got to find the apothem. And if I can find the apothem, I can find the area. Now, when we're looking at a decagon, I could draw out a whole decagon, but I'm like really bad at drawing a 4-sided figure, let alone a 10-sided figure, because that's how many sides a decagon has. So I'm going to draw like 1 or 2, maybe 3 sides of the decagon, and we're going to pretend that the rest of them are kind of filled in, because we can still see that there was a triangle, and we can still use our central angles and everything. So that's how I'm going to draw some of these pictures. I'm not going to draw out the picture every single time. I'm just going to draw a little figure down here. So I'm looking for the apothem. I'm going to draw that in. That's what I'm looking for. I don't know what that is, but I do know that the whole perimeter is 40. And if there's 10 sides, then this whole side here is 4, because if there's 10 sides and the perimeter is 40, that side's 4, which means this little piece right here is 2. And just like we did yesterday, I'm going to use like another color, and I'm going to draw out a bigger triangle because I think that that's really helpful so that we can fill in what we know. This is what I'm looking for. I know that this is 2, and what's that angle right there? Now, all of them add up to 360. I'm going to divide 360 by 10 to get this whole thing. The whole angle is 36 degrees. Therefore, the little angle, or half of that, is 18 degrees. Now, just looking at this triangle here, that looks like a problem that we could have done for chapter 8. We need to find the missing side length by using trig. I have been given my opposite, and I've been given my adjacent, so I'm going to use tangent. Tangent of the angle is equal to opposite over adjacent. You are going to solve for x. There's lots of ways of doing this, but no matter which way, you will end up with this. 2 divided by tangent of 18. Plug all of that in your calculator and you get 6.155 as your apothem, centimeters technically, but we're going to plug that right in to where our apothem goes. As we spent all that time, we found what x is, we found our apothem, I can plug that in, and I'm rounding on my piece of paper here, but you can use your answer button to get a more accurate answer there. Plug that all in your calculator, 1/2 times 6.155 times 40, and your whole area is 123.1 centimeters squared. That's our important piece today, is because we're finding the area. So that's one example. We're going to do one more example down below. Again, the theme is find what is given to you, plug in what you know, and solve for what you don't. Find the area. So we're going to do the same thing. We're looking for the area. We're going to use the area formula of a hexagon with an apothem of 10. Now this is something we haven't done before, where we're given the apothem and we have to look for other things, but it's actually just another trig problem, and it shouldn't be too difficult once we really figure out what we are looking for. So area is 1/2 times my apothem times my perimeter. I already know what my apothem is. My apothem is 10, so I can figure that out. I can just plug that in, and I need to figure out, I know what my apothem is, I need to figure out what my perimeter is. So again, hexagon isn't super hard to draw, but I don't want to spend my time drawing that, so I'm just going to draw one of the sides and pretend that the rest of the picture is kind of filled in there. I know my apothem is 10. And I need to find the perimeter. And I can blow up this little triangle like we continuously do. And if I can find this little guy, I'll be able to multiply it by 12, not by 6. Because if that's there, the whole side would be 2x, and then I would find 6 of those sides. So I'm looking for that side right there. And I can use trig if I know one of the angles, which I do. I can find that angle because all of these add up to 360. So therefore, when I divide it by 6, or how many sides I have, that's 60, and then that angle's 30. We are going to use tangent again, and I'll show you why. Because you are identifying the angle that's given to you. I'm looking for my opposite, and I'm given my adjacent. So tangent of 30 is equal to opposite over adjacent. And this actually is easier to solve because you just multiply both sides by 10. And I know that x is equal to 10 times tangent of 30. And that's going to give me my little value right there, When I plug that in my calculator, I get 5.77. And again, if this was 10, and we can kind of visualize it, if you got like 50 or something, obviously that's wrong. So look for some common mistakes that you could make if you're finding side lengths. 5.77 makes a lot of sense, or 5.773. I'm going to use the answer button. I'm not going to type that into my calculator. But if I know this side and I'm looking for the perimeter, I'm actually going to multiply it by 12. So my perimeter is 5.773 times 12, and my whole perimeter is 69.282. Again, I'm going to leave that in my calculator, but I'm going to plug that in for my perimeter. I'm going to round it there, but I would not round it in my calculator. Plug all of this in. I'm running out of room a little bit, and I don't have this done, so I'm going to do this with you. 0.5 times 10 times my answer is 346.41. Oh, I didn't put one. Why don't we put inches? Inches squared. And that is my final area. So we did 2 examples, one where I gave you the perimeter, one where I gave you the apothem, and you had to find what was missing. You'll see some examples of both today, and I'll also post an optional video that you can look at later.